Hello everyone. Today I am going to introduce the topic probability distributions. I will start with an example of tossing a coin, where that the experiment is nothing but tossing a coin, and obviously we have two outcomes, namely head and tail. So here we have the qualitative aspects like head and tail. We are not speaking here about the quantity. Here we have only qualitative aspects like head and tail. And we can assign the probability of heading the head is 1 by 2 and probability of getting tail as 1 by 2. Now, if we want to process this for some more mathematical concepts, we cannot use the sample space, the qualitative outcomes. So in that case, we can introduce a function, namely random variable. So a random variable is nothing but a function from the original sample space to the numerical sample space. A, this A is a subset of real numbers. So in this case, we are assigning this outcomes of the original sample space to the numerical space. For example, take this head as 1 and tail as 0. Then in future we can use this for any other mathematical prospects. If we take the qualitative aspects, then it is difficult to process. So for that we are assigning this random variable x. So x takes values from the original sample space to the numerical sample space. For example, we take another example like tossing or throwing a 6-faced die. Here the experiment is throwing a die, 6-faced die, and here the outcomes are obviously the numbers 1 to 6. Here, though these are numbers, we can use, of course, as usual, or we can assign like this random variable like S to S. Here we are assigning the sample space S to the same sample space S, because these are numbers, so we can keep this as such, no problem. So here X defines a random variable. X is a random variable and it is nothing but a function from the same space S to S. Here these two are different. S and A are different here. So what is the use of assigning random variable means? For further mathematical calculations, it will be very useful. We cannot use the qualitative aspects as such. So in that case, numerical values are needed. So that is the advantage of using random variables. We have two types of random variables, namely discrete type and then continuous type. So depending on the value of the random variable x, we are classifying them into two categories, namely discrete and continuous. So discrete random variables means random variable x takes discrete or individual values. As we have seen in the previous example of tossing a coin and throwing a die, those are all discrete values. X assumes discrete values. So we have assigned x equal to 1 and 0 and 1 in the first example, and we assigned the random variable x takes the values 1 to 6 in the second example. So work on discrete type of random variables. A continuous random variable is nothing but a random variable which takes values in the interval, in an interval. For example, if we define the random variable in the interval 0 to 1. So x takes all values in the interval 0 to 1. So in that case, we say x is a continuous random variable. So that is the difference between discrete and continuous random variable. Next, we can classify the probability distribution functions according to discrete or continuous type probability distribution functions. So in discrete case, we call it as probability mass function or simply PMF of a random variable. And in continuous case, we call it as probability density function. In continuous case, we call it as probability density function, PDF. The short form is PMF and PDF. Okay. So both are defined by probability of x equal to x. That is f of x. In notation, we use f of x to tell about probability mass function or probability distribution function. Next, we will see the properties of probability mass function. So the first property is probability mass function f of x is always greater than or equal to 0. That is, it takes only non-negative value, because we know that the probability of a function always lies between 0 and 1. Obviously, this f of x should be greater than or equal to 0. And the second property is summation over x belongs to S of f of x equal to 1. That is, the total probability is 1. It's always 1. And the third property, probability of any sub-event A is given by summation over x belongs to A of f of x. That is, this probability of a particular event A. It is given by probability of x belongs to A, that is summation f of x. Summation x over x belongs to A of f of x. So these are the properties of PMF. So in a similar way, we can define the PDF, properties of PDF. In that case, instead of the summation, we use integration. So there is a difference between PDF and properties of PDF and PMF. So in continuous case, instead of summation, we use integration. So that is the difference. Next, I will introduce some of the types of discrete random variables. First one is Bernoulli distribution, and second one binomial distribution, and then geometric distribution, and then hypergeometric distribution, and then negative binomial distribution, and then finally Poisson distribution. So these are some of the discrete distributions we are going to. So a Bernoulli distribution is nothing but whose outcomes have only two possibilities, namely success and failure. A Bernoulli trial is a trial in which the experiments results in only success and failures. The outcome can be classified only into two categories. Bernoulli distribution is the result of Bernoulli trials, so in which the outcomes has two possibilities, success and failure. Hence, the random variable x assumes only two possible values. Has only two possible. Let us take it as 0. So we can use any other values also for this random variable, but usually we use for success 1 and for failure we use 0. So this is the outcomes of the Bernoulli distribution. So in this case, obviously it is a discrete probability distribution because x assumes only discrete values. So the PMF is defined by, PMF of the Bernoulli distribution is defined by f of x equal to p power x into q power 1 minus x. Here x takes only two values, 0 and 1. So this is the probability mass function of Bernoulli distribution. So we can identify Bernoulli distribution by considering the possibilities of outcomes. Okay, so if the outcomes has only two categories, namely success and failure, then we have the values of the random variable x as two possible values, namely 0 and 1 or any other numerical value. Then we can assume this distribution follows Bernoulli. The distribution of the random variable follows Bernoulli. So next we'll see binomial distribution, or we can see the mean MGF and other things, moments of the binomial distribution, Bernoulli distribution. First we will define what is meant by mean of the distribution. So it is given by expectation of x. So expectation of x is the mean of the distribution, and for a discrete distribution it is given by summation over x belongs to S of x into f of. So this is the mean of definition for mean in any distribution. So in this we can substitute the Bernoulli distribution function, this f of x, and then we can derive the mean value. So here x takes only two values, 0 and 1. So when you use x equal to 0, obviously the first term becomes 0, and when you use x equal to 1, then we get, so the mean of the Bernoulli distribution is p. In the same way we can define variance. So variance is given by sigma square. Here we use the notation mu for expectation of x. Variance is given by expectation of x minus mu whole square. Or we can use another formula also, expectation of x square minus mu square. So in the similar manner we can find this value sigma squared as p into q.